Excellent, good. So here we are. And first of all, thanks, Graham, for the introduction, of course. But I mustn't take too much credit for this because I had prepared this talk already. I'd love to say that I prepared this talk specially, but of course I hadn't. So it is recycled, and more than once, because obviously this is a topic that arises mercifully for me every year. But that said, of course, it does get updated. And as many of you will be aware, there was a particularly good reason for updating it this year. And of course, or the last calendar year, that is, but this academic year. I'll come on to that a bit later on. As Graham kindly said, one of the hats I wear, I'm very pleased to be able to wear, is that doing outreach for the Royal Astronomical Society, which celebrated its 200th birthday in 2020. This should say Feast of the Epiphany 2021, of course, here, so that's the first mistake before you start sticking things on the chat. The thing about this year, of course, is that it was very difficult to celebrate anything, but thankfully we managed to get a big shindig in at the beginning of the year, so we at least managed to celebrate something. So the story, of course, begins, the whole idea of the Star of Bethlehem begins with the mention in Matthew's Gospel. Where is he that is born King of the Jews? We've seen his star in the east and are come to worship him. I ought to be clear at this point, I suppose, that of course this is a liturgical subject, it's a biblical subject, but I will be coming at this very much from a scientific point of view. But of course there's more than one dimension to this, and I do acknowledge that. But I'm looking at this predominantly this evening as a scientist. And so what I want to consider, I suppose, is this mixture of the possibility that this is a story which is a biblical ornamentation, or is it an astronomical phenomenon, or is it both, or indeed, are there other things as well which we'll maybe come on to. Let's begin then with the biblical account, and again this is looking at it scientifically. So we're looking for data. Okay, so within scripture we're looking for data here, and from an astronomical point of view, any event that takes place, whether it's something which is observed or something which is being predicted, there needs to be a certain set of data that validates it. So the first thing we're looking at, of course, if this is indeed a genuine astronomical event, is when it might have taken place. And of course, the scripture tells us that we're talking about the days of Herod the King, Herod the Great. So that kind of narrows it all down. Who is it who is involved in this, apart from the Christ child? We're talking, of course, about the Magi here. These are the key figures in all of this. The wise men from the east, they are mentioned. Why were they so interested in it? Well, they've spotted this thing which they called a star, and they've come to worship. And the thing about the word star here is that it has more than one meaning in this context. These days, of course, we think of things which we call stars as large balls of glowing, mostly hydrogen gas, etc., etc. But the word star can mean a number of things in this context. Indeed, we call planets like Venus and Mercury, the morning star or the evening star to this day. Where was this observation made? And by which I mean geographically, so that there was some reason for them journeying. And although they will have spotted something in the sky, as astronomers, we always do record where we are observing from on our planet. And of course, this is in the account as well. We don't know where the Magi were from exactly. We've got various theories, but we certainly know where they were headed. So that kind of sets the scene. I say there are various theories as to where the Magi came from, and this is one suggestion, a sort of Babylonian origin. And if you go onto Google Maps, you can actually see how long it would take to walk from these sorts of lands, these possible lands, taking the recommended route. that Google suggests, and there you are, there you have it. So, you know, a significant amount of time. Now, this is important, of course, because this phenomenon, this astral phenomenon, must have a time scale. There are various theories which we can rule out straight away because they're just on the wrong time scale for what evidence we have. So they saw the star, the Magi saw the star, they headed for where they thought the star meant them to head, what its significance was for them, and they headed in that direction. When they got to Jerusalem, actually in the intervening time, I mean, it's fairly safe to assume that either they didn't see it, either it had disappeared, maybe it was cloudy like it is in London all the time, or maybe it just wasn't astronomically visible. But one thing is for sure, of course, that when they do get to Jerusalem, they're redirected, or they're directed by Herod to Bethlehem. And this whole journey time, as we can see, puts us in the time frame of weeks and months. So this phenomenon that we're talking about really needs to be something which is likely to affect observers for that sort of time scale. The three kings, again, we can talk a great deal about their potential or possible background. But I think from our point of view, the key point here is that whatever their background, it involved them being interested in watching the skies. And I use the word astrology and astrologers with great hesitancy, as many of you know. But in this case, I think it's safe to say that they were astrologers. They were people who studied the skies. They looked for phenomena. They tried to make predictions based on what they observed. What they observed in the night sky was meaningful for them. And, you know, the Zoroastrians and so on and so forth. And we know that all of this kind of stuff is linked in with what these days we would call magic. So it's all linked together. And from their point of view, the significance would have been heightened by anything which happened in the constellation of Pisces. Now, as we know, there are 12 signs of the zodiac, and the signs of the zodiac are constellations, patterns in the night sky, in which the sun appears to move. Now, the sun obviously doesn't actually move through the sky. We are moving around the sun, and it just gives us this impression that the sun is moving. And if we could plot the position of the sun in the night sky throughout the year, obviously we can't see it in the night sky because it's, you know, the sun's up and it's daytime. But if we could, then we would see it moving around the celestial sphere, the night sky, through these 12. In fact, there's 13 constellations, but we only use 12 in the zodiac. And the sign of the zodiac that is associated with Judea and indeed with the Messiah is the constellation of the fish, Pisces. That again will be something that I think resonates with many of us. I just want to pick out two things. Again, this is a section which one could draw out for quite a long time, but I'm just going to pick on two other bits of evidence that are not biblical scripture, which mention things which possibly could be the same astral phenomenon. And this is, as you can see from some Egyptian records in about 2 BC. We need to have a bit of flexibility as to when this phenomenon took place, because of course our calendars have changed over the centuries. And you know, records are such that it really is difficult to pinpoint exactly that this was 2020 years ago. But round about, you know, this sort of time, there is a record of something which was a unique star, according to these Egyptian records. And this was something which was associated, this particular event was associated with the birth of a new king into this world. So there you go, the kind of phenomenon is not unique to biblical scripture. And indeed, a little bit earlier, look, 5 BC, in fact, the Chinese have been observing and recording the night skies for a very, very long time, and their records are usually very reliable. And a thing called, or translated as a bright star, was observed, as you can see, about 5 BC. Again, this word star, we must be flexible with its meaning and interpretation. So I think from the scientific point of view, what I'd like to do is just approach all this by assuming that something happened, that it was observed and it was recorded and it was unusual enough to have caught the attention of accomplished observers of the night sky for whom such a phenomenon would have meant something. So here are my candidates in, I was going to say no particular order, but that's not entirely true, as you'll see in a minute. So I'm just going to look at a few astronomical phenomena which I think could be candidates for this thing that we call the Star of Bethlehem, or more recently the Christmas star. So the first one is, my first candidate is a comet. And comets are amazing objects. Throughout history, they have been regarded with suspicion when they appear, and they're associated with what we call the 4 Ds: doom, death, disease, and disaster. So there's nothing fun really about spotting a comet, unfortunately. So you might think, well, that's not a good start. You know, the birth of Christ, that doesn't really tally with these 4 Ds. But the point is, it was something of significance. The thing about comets is that there are some which we now know return to the Earth periodically. Some, like Halley's Comet, probably the most famous comet, I'll mention that one in a minute, come back every roughly 3/4 of a century. And others, though, just seem to come from nowhere. We can't predict their arrival. We don't know what they're going to look like, how bright they're going to be, and so forth. But we've seen, in fact, in 2020, there was a comet called Neowise, which seemed to come from nowhere. It was obviously tracked for weeks and months before it became visible to the unaided eye. But you know, this is something which was an astonishing sight. If you were lucky enough to see it, it had beautiful tails and so forth. And they do, of course, progress across the sky. And from our point of view, from our astronomical data point of view, in the correct timescale. So it's, in other words, it's not just something which sort of flashes across the sky in a few days or is there for years or anything like this. It's something which is there for perhaps a few weeks, perhaps a few months, and long enough certainly for it to be noticed, and indeed for people to make that journey with it still being visible in their sky. As I say, with many of these things, certainly at the time of the 3 kings, such predictions were just not possible. I mean, the first person to make such predictions was Edmund Halley, after whom that comet I mentioned earlier on was named. And that wasn't for 1700 years later. So the other thing about comets is fair to say is that, as I say, they seem to come from nowhere. They become bright. They will have these wonderful tails, long tails. I'll show you a photograph of one in a minute. And they look, amazing things. So they're very, very significant, without any doubt at all. So that it's a very good candidate. We know a lot about comets these days because we've actually been to one, or at least we've sent probes to comets. And perhaps the most famous mission in recent times was this one to what people call 67P. I'm not going to wimp out. Churyumov-Gerasimenko is the name of the comet, and it's one which is very small and which was orbited by this probe called Rosetta, and then a little part of this Rosetta probe broke away and landed on the comet itself. It was an astonishing mission, as you can see, 2016, and we've learned an enormous amount about what comets are made from, and indeed how they might form. So our knowledge these days of comets is very profound. This is a great picture. It's a composite, obviously, but it gives the impression of this mission. Comets develop these tails as they get close to the sun, because as they get close to the sun, they warm up, they evaporate, and the thing called the solar wind, which is this stream of charged particles rushing out from the sun, will push this evaporated material backwards. Now, you can see there are 2 tails, in fact. There's a thing called an ion tail or gas tail, which gets pushed directly away from the direction of the sun. And then there's the dust tail, which is kind of left behind as the comet moves in its orbit. So you always get 2 tails, one of which, the dust tail, will be usually the more prominent of the 2. Here we are. This is just an excuse to show some wonderful pictures of comets, because they are very photogenic things. And the most famous comet of all, as I mentioned earlier, is Halley's Comet. Now, this is a very, very famous painting, which some of you may know. It's the adoration of the Magi, obviously, that's the subject matter. But just look at the above the stable, and you can see what this artist has drawn as the Star of Bethlehem. It's a comet. It's clearly a comet, and the likelihood of this was painted by Giotto. You can see a long time ago, and during his lifetime, Halley's comet will have been in the skies at some point. We know that Halley's comet orbits the sun periodically, as I say, and it would definitely have been in the skies during Giotto's lifetime. So the likelihood is he saw this comet, he was amazed by it and thought, well, you know, clearly the Star of Bethlehem was a comet, and so that's what he drew. Here's another mission from the last time Halley's comet came to visit our neck of the woods around the solar system in 1986, and this was the probe was called Giotto in the painter's honor, and it was fired straight at the heart of the comet, and there, that picture bottom left there shows us what Halley's comet looks like close up. The probe obviously perished shortly after this picture was taken, but it was again a very successful mission. Don't worry, the comet was completely unharmed. They're big things. And that memorial there, you can see that in Westminster Abbey. It's a wonderful thing. And at the bottom, you can't quite make out the writing, but this is a sort of potted biography of Edmund Halley. And the very bottom line tells us that he laid the principles of actuarial science. So the next time, you know, you're forking out huge amounts of money on your insurance, you've got him to blame. It also features in the Bayeux Tapestry. Remember those 4 Ds I mentioned? Well, this was a pretty, you know, if you were in Norman England being invaded and taken over, this would have been a portent of disaster for sure. And there it is. That is Halley's comet there on the Bayeux Tapestry. So this is a well-recorded, well-documented object. So a comet, that's not a comet you've got on the screen there. A comet, I think, is a very, very good candidate for the Star of Bethlehem. It certainly ticks a lot of the boxes. What's on your screen now is an artist's impression. It's not a photograph. It's an artist's impression of my second suggestion, which is a supernova. Many of you will have heard of a supernova. It's basically an exploding star, but actually it's not a single star. There are several types of supernovae, and the most common type of supernova that we know of is called a type 1a supernova. And it's actually a binary star which goes wrong. You've got these 2 unequal partners in the binary system, and as you can see from the graphic here, it gets swallowed. One of them gets swallowed up by the other, and as it gets swallowed up, it becomes horribly unstable, and that leads to this huge explosion. Now, these are extraordinary objects. They are very rare. And as I say, there's more than one type of way in which a star can end its life catastrophically. But this is a picture of, bottom right, as you can see, of a supernova in another galaxy, a nearby galaxy. And the whole point of this is that supernova there is shining with, you know, a significant amount of brightness, comparable indeed to the galaxy itself. So it is no exaggeration to say that when a supernova explodes, when it goes off, it is shining with the light of millions, if not tens or even hundreds of millions of stars. That's a phenomenal amount of energy and light. They're pretty rare things, as I say. We don't see them very often in our own galaxy. We tend to see them in other galaxies, and as I say, they're bright enough to be spotted in other galaxies. I mean, you know, a galaxy is a collection of hundreds of millions of stars, and yet if one of these guys goes off, then you can still see it because it is that bright. I have a vested interest in this one because a former student of mine, when he was an undergraduate at UCL, was part of a team that discovered this one in 2014. It was completely by chance. They were just testing some equipment on the telescope in Mill Hill, and one of them said, "Hang on, what's that? What's that bright light? That's not usually there." And they discovered this supernova in another galaxy. But again, you can see from this picture how bright the supernova can be compared with, you know, hundreds of millions of other stars. So why does this tick some boxes? It ticks boxes because these can appear, you know, if they're in our own galaxy, they can appear anywhere in the sky. So why not appear in the constellation of Pisces? I'm showing you this picture here because this is not the constellation of Pisces. This is the constellation of Taurus, the bull. And you can see that it's in French for some reason. I don't know why. And there's something called M1 just there on the left-hand side. That is not a supernova, but it's not now anyway. It's this. It's called the Crab Nebula, and it was a supernova in 1054. It's the last really bright supernova to be viewed in our own galaxy, and it was so bright that it was visible in the daytime. And this was recorded by, you've guessed it, the Chinese astronomers in 1054. And this is what it looks like today. It was a star, and it's exploded, and it's now just, it's expanding out into space at some phenomenal rate. And it's worth noting that the catastrophic explosion of a supernova produces conditions in which it becomes possible to produce elements heavier than iron. Now, why is that significant? Well, it's significant because we are made of elements, some elements heavier than iron. There are lots of elements on our planet heavier than iron. And as far as we know, the only way that these elements can get produced naturally is in supernovae. So when our solar system formed 5 billion years ago, 5,000 million years ago, it must have formed from a cloud that had a supernova go off somewhere in its vicinity before our solar system formed. Otherwise, this material wouldn't be here today. So they're very, very interesting things for all sorts of reasons. But from our point of view, from the Star of Bethlehem point of view, why is it a candidate? Well, it's a candidate because it's something which exists on the right sort of time scale. There you are. You can see, don't worry too much about the units, but you can see that this light curve here shows a star becoming tens, if not hundreds of times brighter than it would normally be, and then decaying over a period of weeks, if not months. So it ticks that box of the time scale. It's something which appeared from nowhere. It didn't disappear overnight. It lingered, and then it faded, and it was no longer visible. It could easily have gone off in one of the zodiacal constellations, and as I say, particularly from our point of view, Pisces. So that's a supernova. That was my second candidate for the Star of Bethlehem. My third candidate is a planetary conjunction, which I now think most people have heard of, thanks to something which happened late last year. And this picture, this is actually a screenshot of a wonderful simulation freeware software on something called Stellarium, which I thoroughly recommend. It's an amazing piece of software, and it allows you to simulate the night sky. I use it all the time, actually, if I'm planning an observing session, because it shows me what's visible and where and so on. And this is a screenshot of the skies visible from the UK, from London, on the 1st of April last year. And there you can see 3 planets, Jupiter, Saturn and Mars, very, very close together. And this grouping together of planets is what we call a conjunction. And this is, as you can see, a little animated graphic of a few years ago now, but it's showing Mars, that's the symbol for Mars, which you'll be familiar with, Mars doing this funny sort of loop-the-loop thing. We call this retrograde motion, and retrograde motion is something which means that a planet can approach another object in the sky, or seem to. It's not actually, of course, it's just a line of sight thing, and then double back and seem to move away from it, and then come forwards to it again. So you could end up with one of these conjunctions here. If these 3 planets are all doing that kind of retrograde motion thing, you can see that they would come together, and then they go apart, and then they come together again, and then they go apart, and then they come together. They could do that several times. It's very unlikely that they'd do it more than once, but they could do it a couple of times, and therefore you can get 3 groupings, what we call a triple conjunction, and the triple refers to the grouping rather than the number of planets. And this is indeed something which is predictable now, of course, but it's something which would definitely have been a significant spectacle for us astronomers and astrologers. The reason that planets appear to move this way, of course, is because as the Earth is going around the Sun in an orbit which takes it faster around the Sun than the planets we're observing. So this is the Earth looking out towards Mars, as you can see. If you look at the bottom underneath, you can see that the red dot there seems to go from left to right, and then round about there it stops, and it goes from right to left, and then it stops, and then it goes from left to right again. So it's an optical illusion, of course. The planet isn't actually switching direction; it just appears to do that, and that gives rise to this retrograde motion. So planets are a good candidate really for our star of Bethlehem. The word planet itself means wanderer, a wandering star, because unlike the constellations, the patterns of stars that hold their own patterns, they're the same patterns year after year, the planets are they look like stars. They're not stars, of course, they look like stars moving amongst these fixed patterns. So that's what the word means. Because they are in our solar system, of course, they will move amongst the signs of the zodiac as well. So yes, of course, the planets appear in the constellation of Pisces very, very often. How unusual is a conjunction? Well, you saw that the conjunction that set everybody looking at the skies last year was very rare, particularly a conjunction that brought them this close together. You know, the last time was 800 years ago. And you can see that it's just a line of sight thing. The Jupiter and Saturn didn't physically come close together in space, but they looked as though they were because of their orbits with respect to the Earth. And in 1603, one of the great heroes of astronomy, Johann Kepler, observed a similar conjunction of Jupiter and Saturn. And he thought, well, maybe a conjunction was the Star of Bethlehem. And here's a drawing that Kepler made, or maybe he had somebody draw it for him. And you can see that you've got the three symbols there are going from left to right. You've got the symbol of Venus, and then you've got Saturn. That's the sort of 8 with the cross going on top of it, and then what looks like a squiggly 4 is Jupiter. So it says Mars there, and that's the wrong symbol for Mars. I think that's Venus. So but the point is, it was he was suggesting that it could be a Jupiter-Saturn conjunction with another planet, you know, Mars, Venus, and another planet. He was suggesting that a triple conjunction was probably, i.e. a conjunction between 3 planets that happened more than once, was probably something unusual enough for astronomers, and indeed in those days astrologers, to take note. So this is not a sort of new idea. You know, Kepler has posited this a long time ago, but certainly the one that took place just a couple of weeks ago, was an extraordinary sight. I say that because I didn't actually see it myself. It's even if there was one clear night, the Sunday the 20th, where I went out and had a look. It was clear, but there were buildings in the way, so I couldn't see it. But people who did see it tell me it was indeed a fantastic sight. And here's a little graphic. This is from Stellarium, in fact, I mentioned earlier. And there you can see that point there. They're so close together that they will have appeared as one object. If you looked at that through a telescope, they appear separate, but with the naked eye, the respective glare of Jupiter, particularly of Jupiter, which is very, very bright, you know, Saturn kind of gets caught up in the glare of that planet. So it's that would be something extraordinary. This is a screenshot of that point where they were closest together. So a conjunction is a very powerful candidate, certainly. I'll return to that a bit later on, but my 4th candidate for the Star of Bethlehem is a meteor shower. And I think we're familiar with meteors, these pinpoints of light streaking across the sky, seemingly at random, certain times of year that you're more likely to see them than others. Why is that? Well, the reason is that these things I mentioned earlier on, comets, for example, Comet Halley, in the picture here, and there's another one, Comet Swift-Tuttle. There's loads and loads of comets. As I mentioned, as they get close to the sun, they start to evaporate and they leave behind all this dust. So they leave behind in the solar system these enormous clouds of dust. And as planets move through the solar system, if they happen to intercept these big clouds of dust, then those clouds of dust will enter the atmosphere of the planet if the planet's got an atmosphere, or strike the surface of the planet if it doesn't have an atmosphere, like, you know, Mercury, for example, doesn't have much of an atmosphere, the moon doesn't. And so if you have an atmosphere, though, these little tiny grains of sand, not much more than grains of sand, are moving so fast that they'll burn up in the atmosphere and to produce these points of light. And it's happening quite high up in our atmosphere, you know, 70 kilometers up. above the Earth's surface. So they're very, very high up in the atmosphere. Most of these particles do get burnt up. Hardly any of them ever make it to the surface of the Earth, but some do. But the point is, of course, that at certain times of the year, we would see more of these pinpoints of light, we'd see more of these meteors than at maybe other times of the year, and that's what we call meteor showers. So they're fairly predictable. Now, I don't think it would have been unusual enough for it to have merited journeying from Babylon to Jerusalem and Bethlehem for these three wise men. So it may have been something else. Now, I'm not sure if this is going to work. I'm going to try and show you this this little video here. It seems to be working. That's good. So this is a little bit of footage of a grandmother with it. Do you remember those days where you could cuddle grandchildren and this sort of thing? Well, this is a bit of footage that somebody was taking of that, and then all of a sudden, out of the window, there was this extraordinary sight. So that's what we call a let's just stop that for a second. That's what we call a fireball. Now, the thing about a fireball is that it's obviously an incredibly bright light. It's something which is not predictable, and the key point is it will have landed. It will have landed somewhere. So let me just go back to the screen for a second, and I'm going to show you a picture of something which landed quite a long time ago. If I can resume, here we are. This is a meteor crater in the States, of course, a huge hole in the ground, the Arizona meteor crater. It's the world's largest meteor crater, certainly on land. We may think there may be some under the oceans, which sort of dates when they must have hit the ground, of course. But this is the largest intact meteorite in the world. Now, I've suddenly changed the word from meteor to meteorite. So meteors which hit the ground are called meteorites, okay, just to sort of distinguish them. I mentioned earlier on that most of these meteors are grains of sand, or maybe a pebble if you're lucky, and they burn up very, very easily in the sky. This one was clearly enormous, because after it had disintegrated a lot and burnt up a lot, there was still enough of it there to land on the ground. That lump there, just to give you an idea of the scale, it's about 3 meters across, okay, and it's made mostly of iron. Apparently it must have landed about 80,000 years ago or something like that, but it was only found, whatever found means, in about 1920. So people will have seen it, of course, but it was only sort of broadcast to the world in about 1920. And it weighs about 60 tons, that lump of iron. These things make a massive dent in the ground, as we've seen. Incidentally, that dent that it's in there is obviously not the natural dent. It's sort of made into an open-air museum now, and it's in Namibia. And one day when we can jump on aeroplanes again and go and visit places, maybe we can go and see that. So this would have been something very significant for a set of astronomers stroke astrologers. The thing about the fireball is that it was a one-off, of course. It would have appeared in the sky and it would have landed. The time scale isn't quite right, but nevertheless, it is a candidate. Now, my final one, and I'm conscious of the time here, my final suggestion is this one. And this is a famous physicist called Enrico Fermi, who is famous for lots of things actually in the world of physics, including this famous paradox, which I'll come on to in a second. But just to set the scene, when somebody asks you now how many planets are there, you can say with a certain degree of smugness, oh, well, there's thousands. Okay, people expect you to say 8 and then rattle them off, you know, Mercury, Venus, and so on. But we've discovered now thousands, about 4,000 planets actually. But of course, they're around other stars, and we call these things exoplanets because they're orbiting stars other than the sun. And by the way, this is an artist's impression. Please don't think that all of these planets look a bit like the Earth or Venus or whatever. These are just drawings, speculating what they might look like. But the point is that there are a lot of planets out there in the universe. This photograph here was taken by the Hubble Space Telescope a few years ago now, and every little point of light, every little smudge that you can see in that picture is a galaxy. And galaxies, as I mentioned earlier, contain hundreds of thousands of millions of stars, okay, billions of stars. And each one of those dots is billions of stars. And that square or rectangle on the screen is a tiny, tiny, tiny bit of the sky. So in other words, there are a lot of stars in our universe. And this is one of my favorite quotations, and a bit of fun that I have with students. We try to prove whether this can possibly be true or not, that there are more stars in the universe than grains of sand on the Earth. It's an astonishing thing to suggest, but it's a good analogy. There really are more stars in the universe than grains of sand on the Earth. You know, I can say that without counting them. So what does this mean? It means, this is a horrible looking equation, but it's quite straightforward really, because what it means is that there are so many stars out there that even if a tiny, tiny, tiny fraction of those stars had planets, and if a tiny, tiny, tiny fraction of those planets had life, etc., etc., if we imagine the minuscule fractions of planets that harbor life, that could be intelligent life and technologically proficient and so on, that still leaves you with a huge amount of life in the universe because there are so many stars. It skews that whole equation into saying that there must be lots of what are called in this equation, the Drake equation, communicative extraterrestrial civilizations. So Fairy's paradox was, if there are so many aliens out there, how come we've never seen one? And, you know, it's a fair point. He just said it casually over a cup of coffee at the University of Chicago one day, and people said, yeah, you're right, you know, where are they? So it's not a glib question. It's not a stupid question. Fermi certainly wasn't that. So it's something which, you know, I'm compelled to include as one of my 5 possibilities for what the Star of Bethlehem was. Maybe it was, as Krista Berg so sweetly sings, it was a spaceman that came traveling, and maybe it, you know, maybe it was a craft that landed somewhere in the Holy Land. Now, that it's not an exhaustive list. There will be other things, but as I say, I'm conscious of time, and these are my big 5. Fortunately, as I say, we've had this conjunction take place in recent weeks, and that has really made people think long and hard about the Star of Bethlehem as an astronomical phenomenon. I thought it was rather sweet when people started calling this thing the Christmas star. I think that's great, and it does remind us that you know, that there are things which we observe which we can't always account for, and which we always, as scientists and as human beings, we try to explain. In the current Church Times, here we are, here's my copy, there is an article by this man, Arnold Smith, and I recommend it to you. It's very good, and I'm going to quote him in a second. But before I do so, I thought I'd also share with you, there's obviously a bit of a theme going through the Church Times at the moment, but this lovely little, slightly disturbing picture, 2021, full of new hope and promise. Yeah, okay, perhaps you oughtn't to dwell on that. But there's one other thing which I just couldn't resist, which came to me this morning when Graham was chalking the letters CMB on the lintel of the church. And again, there's Mark Oakley writes a little bit about this in his diary in the current edition. And of course, you know, the CMB stands for the names. You can spell Casper with a K, I know, but I mean, we'll spell it with the C for the benefit of this little tale. But you can also contrive Christus Mansionem Benedicat, Christ bless this house, that's great. But when I saw those letters CMB, certainly as an astronomer, I thought, well, CMB stands for the cosmic microwave background, which is this amazing discovery, which people call the echo of the Big Bang, this microwave radiation which fills the entire universe. So, you know, there's a certain sort of symmetry here. This, as they say, is another story, and perhaps another talk one day. But let's just come back to the thing which has kicked all this off, which is this great conjunction. This is obviously taken a few days after they were closest together, 8 days later, in fact. And if you're wondering who Mrs. R.M. Turner of Torquay is, it's Jackie's sister. It's my sister-in-law. So she snapped this on that night, and she was very lucky. She was blessed with clear skies, clear Devonian skies, and it certainly was an amazing sight for those who saw it. And I think it's worth saying that we need to remember that these are planets. Okay, Jupiter and Saturn are planets. They're moving around the sun just as we do. And their sort of fortuitous alignment, this very rare but very spectacular alignment, has clearly made people think long and hard, not just about the Star of Bethlehem, but also about all kinds of astronomical phenomena, and indeed all kinds of scientific phenomena. And whatever our explanation and whatever our interpretation, I think it's fair to say that we have a very sort of personal journey and a personal interpretation to put on this. And I love what Arnold Smith, in this article I mentioned a minute ago, says. He says, and perhaps we will be inspired to think of Jupiter as not just a stage in planetary evolution, but also as a significant part of God's plan for the whole of creation. And Jupiter is thought by many to be a kind of, a star that didn't quite make it. It's a huge planet. If it had been a bit bigger, perhaps, in fact, significantly bigger, to be fair, then it might have been big enough to have formed a star. So we might have had a double star system in the solar system, and the Earth wouldn't have survived in that kind of environment. But people go on about Jupiter as this failed star. Well, perhaps we can think of it in rather more broad terms than just that. But I think I just wanted to finish really by quoting something which, of course, is part of our Christmas celebration. Whatever the phenomenon is, whatever the phenomenon was, whatever phenomena there might be in the future, the fact is it's all part of God's creation. All things were made through him, and without him was not anything made that was made. And I think that's as good a point on which to finish as any. Thank you very much, and I'm very happy to stick around and take any questions or welcome any comments or criticisms for that matter as well. So please do fire away. Thank you, everyone.